So thank you, everyone, and welcome to this introduction to the Neurorobotics Platform. Again, yes, you know my name, and you know actually that I come from Italy, and where I received my bachelor degree in industrial engineering with specialization in biomedical engineering. So I had there an introduction about biomimetics, neurology, and physiology, anatomy, etc., and biomechanics. And then I decided to move to Denmark, where I graduated in automation and robot technology, so kind of something totally different, some way, engineer. And so I'm in Copenhagen, and I work as a research assistant at the DTU Neurorobotics group together with my colleagues here. And basically, our main objective is to get inspiration from brain areas like the cerebellum, and implement, design some biomimetic architecture for motor learning and control of compliant robotic system. In particular, we work on modular robots. So maybe some of you don't know what modular robots are. Here are the picture of this. Basically, are particular robots that they follow some kind of Lego theory. So you have different modules that you can combine together in order to have a different robot morphology. So every time you can change your robot system and or plug them together and do some different experiments also online. So for example, here I'm showing a quadruped morphology, where I have 4 active model and 2 passive model. Okay, so today agenda. I thought that to have a clear idea about the concept behind the Neurorobotics Platform is maybe better start looking at what Neurorobotics is. And then it would be also nice to see how neurorobotics is related to the Human Brain Project and wherein the Human Brain Project is. Then finally, we'll have an overview of the Neurorobotics Platform. So again, what is neurorobotics? Let's start from the base. So all the biological systems are in some way perfect, in their own way perfect. And this is due to the fact that they are the result of an evolutionary process. Let's think that most of the time we tend to underestimate anything we are doing. Like in this moment I'm talking, and at the same time I'm moving my hand, I'm moving my legs, I'm watching there, I'm listening. Maybe sometimes I get distracted, okay, by sounds. I tend to filter some specific sound, and I'm doing everything now without any effort in some way, or just with a little effort. But I mean, if you start thinking about it, if you start thinking about all this action in a more scientific way, okay, and maybe you want to try to reproduce it, then you start understanding that all those actions are really complex and really difficult to mimic. So humans always try to get inspiration from nature. That's why I decided to put the picture from one of the main actors in this, which is Leonardo da Vinci. He always tried to take inspiration from nature, from birds. He wants to develop, design his own mechanism to improve what the society have and take inspiration from nature. So we wonder, is it actually possible to mimic nature in order to design and develop such sophisticated, robust, and adaptable artificial system? In particular, in my opinion, the most powerful creation of nature is actually the central nervous system, because it's really astonishing, it's incredibly complex and tremendously powerful. And just think that all the billions of information, sensory information, the central nervous system receive all together. And anyway, it can react, it can control every aspect of our sensation and movement. If you try to do the same with a robot, then you have to wait ages before it's analyze, it process all the information and combine them together if you can actually handle that. So, moreover, the central nervous system doesn't work alone. It has a mean, it has a body, for a body that is used to interact with environment. Through the body, receive those stimuli and react and interact. So here is where neurorobotics is in action, because neurorobotics is a strategic alliance between different research fields such as neuroscience, artificial intelligence, computational neuroscience, robotics, and control, that altogether aim to help the scientific community to better understand the brain. Because once we can understand this complex mechanism, this small at the end and complex mechanism, so maybe we can find the solution to a lot of problems, to a lot of brain disease, for example. Because once you know the problem, then finding the solution is much easier. At least you know where is the problem, where to look at, the source. Moreover, if we can understand such complex structure, maybe we can develop some new artificial mechanism. So, neurorobotics basically is about merging knowledge. If we start from neuroscience, neuroscientists, through experiments, through the observation of nature, of the biological system, they get experimental data. And thanks to this experimental data, they can actually assume theory. Here the speculation start. Okay, for example, the problem is this is most of the time are just speculation, and it's really difficult to study some specific area of the brain to actually have information from specific population neurons that maybe are really important in the functionality. For example, in my laboratory we studied the cerebellum, and I mean, I respect to the whole brain. The cerebellum is just a small part, but in its compact structure is full of layers, full of neurons. It handle a lot of information together. And about those populations that are inside the cerebellum, there are still a lot of assumptions that are not clear. A lot of like connection that are still not clear to neuroscientists, and it's still not possible to actually validate those assumptions. So here where computational neuroscience bring all those theoretical assumptions and convert it into mathematical model. So here we start talking about model, the concept of model, okay? And it needs to be really clear that the model is not a real system, okay? It's just a description of the real system under certain assumptions, under certain constraints and conditions, okay? So here we can argue a lot, what's the sense of having a model when you need a real system functionality or these kind of things? Well, when you have such complex problem, it's better starting splitting it in simple problem and then adding complexity step by step. Okay, so actually, so now we have a mathematical model. We can describe the behavior of the neurons. We can input this model into the computer, transforming them into code, and we can here there will be lots of argue about, I don't know, neuromorphic SIP or these kind of things, that they use all these mathematical model to reproduce the functionality of the different population and the connection between the neurons. But yeah, so here we are. Then all these bio-mimetic models are used then by roboticians and control engineers that combine them together and use them into practical experiment. Okay, and you can actually see that there is a big difference going from just assumption to mathematical model. Then you compare the data with the experimental data, yes, and then you can say that if the mathematical model are validate. But what happens if you can actually use those models and see if they work also on artificial mechanism? Then it is another validation, extra validation that you have of the theory. Because if you're assuming, for example, that the cerebellum is a key actor, one of the key actors in motor adaptation, motor learning, and you actually see that a robot can actually adapt in a changing environment, it can actually learn is motor primitive, then that's amazing because you are validating the theory. Okay, so, and moreover, what happens if you combine together all those different brain area models? Okay, so the cerebellum, you bring the basal ganglia, the hippocampus, and you try to understand how they are related, how they are interconnected to each other. And then you can create a wider brain architecture, and you can actually validate the other assumption about the connection between them. And this is another key, another point that is really difficult to validate. And obviously then robots interact with the environment and with the biological system. So in some way we can close the loop. So what are the advantages, or which advantages we will have in future? Okay, once the artificial mechanism will be as close as possible to the real system, then maybe that will mean that we will be able to reduce the need for animal experiment, because we will have some some artificial systems that are really close. So when we need to test anything, we can just do it, and the validation of the experiment will be also faster, because we can also try it in practice. And on the other hand, from the artificial system point of view, if we can actually mimic those complex systems, then maybe we can boost what we have. We can have a faster, more flexible and capable real-time learning and control. And we can boost the interaction capabilities of the robot. And here is connected to the last point, because we can say that there will be an improvement of neuroprosthetics. So, and the neuroprosthetics are the kind of mechanism, artificial mechanism, that are always in interaction with a human. And that's a big problem, because they need to be safe. They need to handle different situations. Let's think about prosthetic hand. We don't think that, but every time we handle an object, the condition change. It depends on the object, depends on the situation, depends on anything. Maybe my hand is hurting, then I start handling the object differently as I used to do. And this is crazy, because our body, our central nervous system can do it fastly, easily. Why in robot this is still not possible? There are so many manipulation action that the robots are not able to do. So now I think we can relate neurorobotics to the Human Brain Project. It will be just a short introduction to that, because I guess most of you know. So in the Human Brain Project, we are more than 500 scientists from 117 institutions that, so it's a big project, it's a really big project. It's crazy how big is it. And we are split in 12 sub-projects, but those 12 sub-projects are done in such way that we are interdependent from each other. We collaborate, we share information, okay? And we are actually building 6 web-based platforms that everyone can use, that are public, in such a way that you can share with us your experiment, your opinion, your knowledge. So we can find, for example, the neuroinformatics platform, the medical informatics, the neuromorphic computer, so the Spinnaker, and the Neurorobotics Platform. All together, we have a common vision, which is understanding the brain, because understanding the brain will give us a profound insight in what makes us human. And once we understand the brain, it will be possible to understand also the brain disease. So again, to find, knowing the problem, we can actually find new treatment, solution to the brain disease. And at the same time, we can develop new revolutionary computing technologies. So again, our aim is to get inspiration from the brain. So, but where is neurorobotics in the HBP, where we are? So, those are my colleagues, part of them. We are in the Subproject 10, and our aim altogether is to try to incorporate all the neurorobotic concepts that we have been talking about in the past few slides in an open source platform. In this way, everyone will be able to connect the brain model, and sorry if I use brain in this way, some of them could argue about that. Let's say maybe neural circuit inspired by brain, on a virtual or even real body. So in this way, everyone will be able to explore how the brain controls movement, react to stimulus, and learn in virtual environment. So also here, maybe we can argue a lot about the virtual simulate system, real system, these kind of things. But again, it's a really complex problem, so it's better starting splitting in simple problems and then adding complexity again. So the idea is that everyone can collaborate all together, and this can be done through having a platform where everyone can access, and the easy access is something really fundamental, because, for example, I'm here today with my laptop, and usually around the platform on my desktop computer, okay, but I can run it also here. I can bring my experiment from here, and I'm not in Denmark, I'm in Munich, so that's really nice. And also you can is implemented in such a way that you can share research. You can use other research experiment, other research model. You can use robots that maybe you don't have it, okay. And so another fundamental concept, okay, behind the platform is that you don't have to reinvent the wheel. Let's say that, because you can just use, you can start at least with the tools that are provided to you, robotics tools that maybe you don't know at the moment, but you will learn, and neuroscience tools, and combine them together like Lego and build up your own experiment. So you don't have to start from zero every time. And that's it's not trivial at all, because you don't have to, experiments take a long time, and the 90% of the time is about frustration, trying to make the experiment work, and arguing against the code, maybe against the computer, because for a stupid comma it doesn't compile, or these kind of things. And then the rest of the time is about, it's a joyful moment because something works or maybe not, and then you have to come back. So it's better if you have something pre-implemented yet, and you just plug in everything together, and then you can develop your own, maybe, okay? So you can mimic again. And so any user in the platform will have to be able to use the brain model that are developed between the HBP, or maybe from outside, or the user can develop and test his own model, because maybe once you see how we develop our brain model, you can actually have some nice intuition. You can understand, we call it inverse engineer. Basically, you start from something done, you decompose it, you understand how it works, and then you create a new one from scratch. Yeah. Okay. So why virtual neurorobotics? So here I will give my opinion from a repetition point of view. Every time I need to start a new experiment, and I can choose between using hardware directly or software. And I know that the control architecture is really new, because this is how research works. You try to do something new that no one have done. Okay, I prefer using the simulated robot because several reasons. Most of the time, hardware have lots of problems, so you spend a lot of time trying to understand why the robot doesn't work. Maybe it's a stupid thing. Maybe, I don't know, something burned, or the battery, or something like that. And then you have to wait for the new battery to arrive, and then you lose a lot of time. And time is precious. Well, instead, if you use a simulated robot, you just plug in your code, you set up a little bit, and you can easily test all your experiments. So in some way, also another thing is that robots are really expensive. And having a robot, even in university, you don't have a wide range of robots at the end. If you want to try on different robots, that you can really do it. And if you run an experiment for the first time and you are not really sure about the output of the experiment, then you really risk to break the robot. So using the simulation, at least if the robot starts slapping itself, it's fine. I mean, at least you will start laughing too. I mean, I saw, like last year, I used a lot of robot manipulator like that one, and like this one, industrial manipulator, and most of the time at the beginning my robot was just turning around itself like dancing. It was really funny, but if it was on the real robot, like the universal robot, the UR10, which are really big robots, that's really scary. Okay, so again, it's fast testing, yes. So because you can just plug in and test again, and every test has the same condition, so you repeat the test without any deviation. And that's really important, because maybe on the real robot, because the battery is really low, then you have some result that are totally different or kind of different from the previous one. And that means a lot when you have to write a paper or something like this. And and also you can find a lot of tools easily, like sensor, for example. You can find all the information about the sensor. You just download it and plug it in the simulation, and you test the sensor before buying it, because that's also another expense. So here we can talk then about the Neurorobotics Platform. You can find it online on the website neurorobotics.net. You can see there are different sections here. You can look about, I think maybe you can read it, isn't it? You can find some information about the team, so about us, the partners, the cooperation, events, if you want to join us in other workshops or events. You can find our publication. We also have a blog where we write about our experiments or about places we went or these kind of things. And there are also open positions if you want to join us. If you scroll down the page, you can find some useful links, like how to get an account, some online demo, the online platform, and the installation, the Bitbucket installation. There is also a manual, really nice manual, both for users and developers, and video tutorial. And if you experience any problem with the platform, or you can actually find out that something can be improved, and there are some features that are not present in the platform and you will like them, then just ask. Because for us, again, it's really important, the collaboration. We want to build something that everyone can use, because collaboration will lead us to improvement. Sharing information helps us a lot. So yeah, we also have a forum where you can see a lot of people complain maybe about problems. And yes, we are a community. We try to help each other. That's really important because maybe is, I don't know, a day that you are struggling with a problem and then you don't know how to do it and there is no one that can do it. But then there is the forum. You can just go on the forum and write, hey, please help me, I have this problem. And maybe someone have experienced that problem and will help you immediately, or maybe not, it depends. Or maybe if the problem is not that solvable, then the developers will think about it. So again, the NRP is completely open. Everyone can use it. And please, you're welcome to give us feedback, to give us suggestion, because it will be useless if the user cannot actually use or find it difficult or doesn't have the tool that he wants. So yes. So you can find also regular updates on our website and come to our workshop to talk with us or, I don't know, write us. So thank you very much. I hope it wasn't too boring. And yes, soon we will start with the tutorial. I hope that it will be funny at least. Okay, so thank you.